Hi. So here we have the differential equation given by x minus y times dx plus dy equals to dx minus dy. So we have to find a solution to this differential equation by using the method of variable separation. So let us begin. We'll first rewrite this differential equation as x will multiply x at dx plus dy. So that will be x dx plus x times dy minus y times dx minus y times dy. So that's equals to dx minus dy. Now we'll keep all the dy terms on one side. So we have x dy minus y dy. We'll bring this negative dy from the right hand side to the left hand side. So it becomes positive dy. And we have dx on the right hand side. And we'll take this x dx and negative y dx to the right hand side. So we have positive y dx minus x dx. I will take dy as the common factor. So that gives us x minus y plus 1 times dy, which is equals to, so here we have 1 plus y minus x times dx. Separating the differentials, we have dy over dx equals to 1 plus y minus x divided by, so this will be x minus y plus 1. So this is quite clear that we cannot separate the variables. So we need to do a little bit of manipulation here. So we will rewrite this dy over dx expression on the right hand side as dy over dx equals to, so we'll take negative common, so that will be x minus y minus 1 divided by x minus y plus 1. Now we will make a substitution. Suppose x minus y, let this be equals to some variable v. Then we differentiate both sides with respect to x. So this will be 1 minus dy over dx, which is equals to dv over dx. Isolating dy over dx, so we have dy over dx equals to 1 minus dv over dx. Now what we'll do, in place of dy over dx in this particular differential equation, we'll replace it with 1 minus dv over dx. So let's write it down here. So this will now become 1 minus dv over dx equals to, we have negative, whole multiplied to x minus y, so that will be v minus 1 divided by v plus 1. So we now have dv over dx, so that will be 1 plus v minus 1 over v plus 1, and this is equals to v plus 1 plus v minus 1 divided by v plus 1. So the 1 and negative 1 gets cancelled, and that leaves with 2v in the numerator divided by v plus 1. Now what we can do, now we can separate the differentials. So this is going to give us dx equals to v plus 1 divided by 2v whole multiplied to dv. Now this is in the variable separable form. So that means we are ready to integrate both sides. So integration of dx will be simply x plus we have half integration of dv plus half times integration of dv over v. So x will be equals to half integration of dv will be v plus half integration of dv over v. So that's natural log of v plus the constant of integration c. Now we will substitute the value of v with x minus y. So this will give us x equals to half of v. So v is x minus y plus half of natural log of x minus y plus the constant of integration c. So this will be x equals to half of x minus half of y plus half natural log of x minus y plus the constant of integration c. So this negative half of x, when we take it to the left hand side, so we x minus half of x, so that will be simply half of x. So we have half of x plus half of y equals to half of natural log of x minus y plus the constant of integration c multiplying throughout by 2. This will give us x plus y equals to natural log of x minus y plus 2c. Now, we have an initial condition which I forgot to mention in the question. So the initial condition is y of 0 is equals to -1. So we'll be using this initial condition to determine the value of c. So let's use it. So we have y of 0 equals to -1, which simply implies that when x approaches the value 0, then y is going to approach the value -1. So we have 0 plus, and now y is -1, 0 minus 1 equals to natural log of 0. So we have minus of -1, so that's +1 plus 2c. So this is -1 equals to log of 1 plus 2c. We know that log of 1, that's always 0. So that leaves us with c equals to -12. So let's substitute the value of c with -12. So our final solution then will be x plus y equals to log of x minus y. We have plus 2 times -12. So this will become -1. So that means our solution is x plus y. So we can bring this 1, this is -1, to the left hand side. So we have x plus y plus 1 equals to log of x minus y. And if we use the definition, then our x minus y will be, absolute value of x minus y will be simply equals to e raised to the power of x plus y plus 1. And this is the final solution to our given differential equation.